Okay, so we're going to continue working on applications of the integral today. We'll talk about density and mass. Upcoming things, Project 5 is due next time I see you, which isn't until the Monday after break. So you have all the break to get Project 5 completed, which is the Candy volume project. I have Project 6 to give you, so you can take it over break if you are interested. You will probably have to do a little bit of reading ahead in the textbook in order to make any headway on that. It's about work. There's an economics application, and then there's one other application, but I can't remember what it is right now. So you might have to do a little bit of reading if you wanted to start on that over break. Okay, let's see. Today we're going to use calculus and the methods of slicing again that we've been developing, and we're going to be calculating mass based on density. All right, so this simple non-calculus problem, if you want to find the mass of a cube that has side length 3 inches, so I'll draw my little cube here. All the sides are 3 inches, and it has a density of 2 pounds per cubic inch. How would I calculate its mass? 3 times 3 times 3 times 2. Yeah. So its mass would be 3 cubed. Let's put units here. This is inches, 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 and then 2 pounds per cubic inch. Right, so all my units cancel, all my inches cancel. I have inches times inches times inches on top. So this becomes 27 cubic inches times 2 pounds per cubic inch. Cubic inches cancel, and you just get 54 pounds. It's the mass of the cube. So in general, density is the concentration of mass in an object. It's usually measured in units of mass per volume, for example, grams per cubic centimeter. So a solid with uniform density, if the density in the whole solid is constant, can be calculated, its mass can be calculated by just doing volume times density, which is what we just did up here. We found the volume, 27 cubic inches, multiplied by the density, often denoted with a delta. Okay. Volume times density. You could also use density for 1 or 2-dimensional objects, right? So in 1 dimension, mass is distance times density. In 2 dimensions, it's area times density. All right, so that's just some basic physics relationships. No calculus so far. Where calculus comes in is if the density of the object varies, right? If the object doesn't have uniform density throughout. So the above formulas no longer hold, and you have to use calculus to calculate the total mass. So to do this, you slice up the object in such a way that each slice has approximately uniform density. Use the easy formulas above on each slice, and then you add all the masses of the slices up. Okay? And then once you let the number of slices go to infinity, we've created an integral. So we'll do one example together, and then you've got a bunch to do in your activities. So we have an open cylindrical barrel, diameter 7 feet, height 21 feet. It's filled to a depth of 10 feet with muddy water. So let's try to draw a picture. We've got a barrel. It's 21 feet tall. And the diameter is 7 feet, so I'm just going to put in the radius of 3.5 feet because we typically use radii more than diameters. Okay, so this thing is filled up to 10 feet with muddy water, so about halfway full. This is all muddy water down here. All right, so Muddy water, more mud tends to be at the bottom of the barrel, right? The mud kind of settles down at the bottom. So the density of the mud in the water is not constant. There's more mud at the bottom than the top. And they tell us about how it varies, right? It says the density of the water varies linearly with the depth of the water. So we've got density and depth. Those are two things that are varying here. So let's say that this will be a height of 0, and we're just going to mark a random height h. So we're going to look at a random slice of the water. So we're looking at like a slab of muddy water. It's got a little bit of thickness, but very, very little thickness. It's got a little bit, but just enough so that we have a slab, but it's small enough that we can say that on that slice of water, the density of the mud is going to be approximately the same throughout the whole slice. All right, so we're going to call that a height of h. And then at different heights, we have different amounts of mud. Okay. All right, so the density of the water varies linearly with the depth of the water. If the density at the bottom is 80 pounds per cubic foot, so the density at the bottom is 80 pounds per cubic foot. So can we translate that to a point in the form h comma delta, a height with a density? 0 comma 80, great. Okay, and then my next sentence says the density at the top, at where the water stops at 10 feet, right, is 30 pounds per cubic foot. So if I translated that to a point, I would get 10 comma 30. Good. So I could write an equation of a line. How do I know it's a line? It says it varies linearly. Yep. So I could write an equation of a line where I could find my density as a function of my height. Just find the equation of the line through these 2 points, and you get negative 5h plus 80. Okay. I assume we don't have to review how to find the equation of a line. Okay. So now I know at any given height h, I could calculate the density of the mud in the water. So my question is to find the total weight of the muddy water in the cylindrical barrel. How much total weight is there in this 10 feet of muddy water? So let's look at a single slice. I kind of colored this pink random slice at a height of h. I'm going to draw it over here. This is a slice of muddy water. A little bit of thickness. Okay. What is the radius of my slice? 3.5. It's constant throughout the whole barrel, so I can just label that 3.5. What's the thickness of that slice? Delta H, yeah. You could have called it Y, but yeah, I called it H. So the thickness of that slice is delta H. I'm looking for the mass of the water, so if I can find the mass of a slice, I can just add them all up. So I would like to know the mass of this slice. Okay, and remember mass is volume times density. Okay, so that's the volume of the slice times the density of the slice. Okay. So what's the volume of that slice? How do you find the volume of a disk? Pi r squared h, yep. So this is going to be pi times 3.5 squared times delta H. All right, and then what's the density of the slice? Negative 5h plus 80. I can calculate the density at any given height h using this formula. Okay? So I picked a random slice at a height of h, which means its density is negative 5h plus 80. Okay, so put that here. All right, so if I can find the mass of one slice, I can find the mass of everything by just adding up a bunch of slices. Okay, so the mass of the water total is the sum of a bunch of slices that look like this. Pi times 3.5 squared. I'm going to put the delta H at the end. It's 80 delta H. Okay. I should have called that approximate, right? And then to get the exact total, take the limit as n goes to infinity here. The number of slices goes to infinity, and you get an integral. So total mass of the water is going to be an integral of pi times 3.5 squared times negative 5h plus 80. When the number of slices goes to infinity, the thickness of each slice becomes infinitesimally small, and that delta H becomes denoted a dH. And now I just have to figure out the bounds of integration. I'm stacking my slices at various H values. The smallest value of H would be 0, and what's the highest value of H? 10. Yeah, because the water only goes up to 10 feet. So this is 0 to 10. And then that's a pretty easy integral to calculate. You can pull out the 3.5 squared pi. The antiderivative of negative 5h plus 80 would be negative 5h squared over 2 plus 80h. Evaluate from 0 to 10. All right, so if I plug a 10 in there, I get h squared is 100, negative 500 over 2 is negative 250. Negative 250 plus 800 is 550. And then when I plug a 0 in for h, I get 0. And I'll just get an approximate value for this. When you're asked how much the muddy water weighs, if you leave pi in your answer, you know, the person who asked might be annoyed at you. So 3.5 squared times pi times 550 is 21,166 pounds approximately. Just round to the nearest pound. Let's just have the calculator double check our integration here. It's a great thing about the graphing calculator. All right, so I'm going to function integrator of 3.5 squared times pi times negative 5x plus 80, integrating with respect to x from 0 to 10. We did it right. All right, so same game that we've been playing for the past couple of days, right? Slice it up, add up all the slices, turns into an integral. So that's it for the demo. You've got 5 problems for your group activities. I asked you to just evaluate using technology, right? So you don't have to practice integration until the very end. Once you get through the 5 problems, just setting up the integrals, then I tell you to go back and try them by hand, try to do the integration by hand just for practice. But the main point of today is to learn how to set up the integrals.